So we already learned the basic Python about some classes like what is the object, what are the built-in classes, and then what is Boolean, what is integer, float, and we already learned about list and tuple. Okay. So by now you know what is the difference between tuple and list. So let me review a little bit. When you use list, you need to use the square bracket. When you create tuple, you use the common bracket, or this is the parenthesis. Later on, we will check another type of data structure in Python, okay? But now, because this is for list and this is for tuple, okay? And when you use list, it is almost the same with array. We can just call the index, as we already learned. List is array-based sequences, and the list length n has element index from 0. So if we have like 3 elements, 1, 2, 3, then this is index 0. This is index 1, this is index 2. And whenever we want to change from the list, yeah, we can change. But if we use tuple, we cannot change. Okay, that's the difference between list and tuple. So empty tuple is just a parenthesis. We call it parenthesis. Empty tuple is just a parenthesis, so it means no element. To express a tuple of length 1 as literal, a comma must be placed after the element, but within the parenthesis. Okay. This is one element tuple. If you don't put any comma, there might be some possible error. For example, if I put 17, yeah, this is possible. Okay. Or let's say I have this is possible, but it will be good practice if you put the comma 17 comma for a tuple with one element. Next, we have a string class, str. So str or string, it can be enclosed in single quotes. Single quote, this one is single, or double quotes. So this is double quotes. A string can also begin and end with 3 single or double quotes. So 3 single or 3 double quotes. And it will contain new line. So if you have print welcome to Python class, this is the beginning of data structure and algorithm. Good luck. And then you close with 3 double quotes. Okay. If you run this, then the structure will be in 3 lines or multiple lines. You can also change with the single quote. Three single quotes, so it will show you the same. Okay, because in a string you will have the same with either double quote or single quote. Set. What is set? Python set class represents a set, namely a collection of elements without duplicates and without an inherent order of those elements. Okay. So the key point is without duplicates and without inherent order. Only instances of immutable types can be added to Python set. So the immutable means unchangeable. Therefore, objects such as integer, floating point, strings are eligible to be the element of set. The frozen set class is an immutable form of the set type itself. So I will just focus on the set. Now, when you learn about lists, you know that we will use the square bracket. When we use tuple, we know we use the parenthesis. But when we use set, we will use curly bracket. Okay. This is the curly bracket. And we can specify like we use list. So we can put the element inside. We can put the element inside. The only difference is the first representation or the delimiters. So the exception to this rule is that the empty, like this one, does not represent any empty set. So there is no empty set. So if you want to create an empty set, you need to use set. Something like this one. Set with the common parenthesis. So let's see. Let's suppose I have set 1. So if you use the word set, you can see it is not available for being the variable, okay, because it is one of the reserved word in Python. What about if I use this one set? It is also not possible. Why? Let's say this one. So it is invalid. Do you know why? Because it starts with number. Okay. If you still remember with the identifier, this one. Okay. Identifier can be composed of almost any combination of letters, numerals, and underscore characters. And an identifier cannot begin with a numeral. So you cannot start with number. Okay. So let's say I have to set 1. Okay. And I would like to make something, for example, A, and then A, and then B, and then B, and then C. So I have duplicate. I have duplicate. It means there are 2A and there are 2B. Okay. when I call set 1, then I can get only the unique element, only A and B and C. Okay. Now, you can see that it is in the order A, B, C. Okay. Actually, it is not in the order. Okay, this is just, yeah, maybe fortunately this is in order A, B, C. Let's say if I have set 2, A, B, A, C, B. Okay. So if I call set 2, okay, this is still A, B, C. Okay. Because it shows A, B, and then C here. So let me check if this one C and then B, B. This is still A, B, C. Okay. So the order is not a matter. That's why you can see here without inherent order. So there is no order. And for the set, okay, okay, maybe I will explain later. The next, after the set, we will learn about the dictionary. Python dict or dict, it is a class to represent dictionary. So we will do a kind of mapping. We call it, this is mapping from a set of distinct keys to associated value. So we will have K and we will have V. K means key and V means value. So Python implements a dict using almost identical approach that of a set. So it is the same with set, but with storage of the associated values. So the literal form is using the curly braces. It is to produce empty dictionary. Okay, so if you use square bracket, you will have empty list. If you use parenthesis like this, you will have empty tuple. If you use curly bracket, empty, it means it is empty dictionary, not empty set. Okay. So if you want to make empty set, then you need to define set with the parenthesis. So non-empty dictionary is expressed using a comma separated series of a key and value. So usually we use K to represent key and value V, and it is a pair. So for example, I have the GA, it is to represent the iris, and then DE to represent gem. So this is the key and this is the description or values. This is the key and this is to represent values. Okay. So this kind of dictionary is similar like when you want to translate a word. For example, you have Hakyo. So you can represent Hakyo, it is the key, and then you can say this is school in English. Then the key is Hakyo and the value is school. If you have another dictionary, for example, pet, then it can have three meanings. So you can also have the value is both. You can have the list both and pair and stomach. So something like this one. It means one key, it can have several values. Alternatively, the constructor accepts a sequence of key value pairs as a parameter, and we can just call the class dictionary, and then the parameter is in the form of list. So for example, I have the dictionary 1. Okay, let me have the GA iris, and then I have the DE is German. So this is the dictionary, and I want to get the value of the GA, then I can call GA. If I call the key, then I will get the value. And let's suppose I have a list. So I have a list, and inside the list I have tuple. Okay, and the tuple I have two values. Let's say, okay, let me just have this one. So I have two tuples. I have two tuples inside a list. And then I say I have the dictionary 2, and I want to make it as pairs. So I want to change these pairs into dictionary. Okay, let me just check dictionary 2. And then I am going to use the class dictionary, DICT, to change this list into dictionary. Then I will get in the form of dictionary. Okay. Expression and operators. Existing values can be combined into expressions using special symbols and keywords known as operators. The semantics of an operator depends upon the type of its operand. So for example, when A and B are numbers, so the A plus B indicates addition. If A and B are strings, then plus indicates concatenation. Maybe I can give you examples. 3 plus 5, it means the addition of the mathematical. But if I have hello plus word, whatever, it will combine the string. So if I have 3 plus 5, what is the result? String plus string. The result is string. And the result is 35. Okay. It is the combination of the string of 3 and the string of 5. What if I combine 3 plus 5. What is the result? Error. Okay, so you need to use the same data type when you do with these operators. Okay. Let's say I have 3 plus 5. Is it working? It's also not working. Okay, so you need to have the same data type for the operators. Logical operators. When you have the logical operators, we have not, we have and, we have or. The and or operator short circuit in that they do not evaluate the second operand if the result can be determined based on the value of the first operand. So here, maybe first I will give you something like this operator. The operator is not only the addition, but it can be another, for example, like this. What is the result of this operation? False. It's true. Why? It is based on the ASCII number, if you still remember. This is the standard code, okay, American standard code. So if you look at the table, okay, the number 8s, okay, the big 8s, the number is, when we use this decimal, it is 72. And then when we use the small 8s, the number is 104. So they check based on its number of the characters. In this case, they will check 8s, small 8s, and then the big 8s. Because this one has the higher number in the decimal of the ASCII, then yeah, it is true. What about the remaining? They don't care, because they already found the first, which is true. Okay. So if you have A, B, C, D, E, F, of course, we will know that it is false, because D, E, F has higher value than A, B, C. Okay. And yeah, we can have the not and or. Two greater than 3 and 5 less than 3. Two is greater than 3? No. Then the computer will not check the remaining. because they know that it is already false. And this one is using the AND operator. Okay. What about if I change this one to OR? This is still false because I think 5 is less than 3 is false and false, so false. Okay. What about if I change this one false and true? Then it is true. Okay. So it is based on the mathematics. If we have P and Q, okay, and let's suppose we have the N. So if it is true and then it is true, then the result is true. If it is true, if it is false, then the result is false. If it is false, it is true, the result is false. If it is false and it is false, the result is false. Okay. If we have OR, then it will be different. If we have OR, if we have true, false, then the result is true. If we have true, we have true. We have false, we have true, the result is true. We have false and false, so it is false. Okay. Usually we use this operator as OR, and then we use this operator as AND. Okay, that's the logic of AND and OR. We can use the not 2 greater than 3. Then the result will be the opposite. Okay? The opposite of this one, because it is false, the opposite will be true. So we call this is the logical operator. Python supports the following operators to test two notions of equality. So we have is not, equal, and not equivalent. The expression A is B evaluates to true precisely when the identifiers A and B are aliases for the same object. What does it mean? When it is the same object, so if it is list, then they are in the same list. Okay. If one variable is list, the other variable is tuple, then they are not same, even though the elements are same. The expression A equal B are more general notion of equivalence. So let's see. I have A, B, C. And then B, I have B, C, D. A is B. False, because all the elements are not same. Okay. So let's see if I have C. Okay. B is C. It's not same. Why? So B is not C. True. A is not B. True. So it should be precisely the same. Okay. When you check this one, we can use the equivalency. B equal C. It is more general. Okay. A equal B is false. Even though they are the same, but is does not represent exactly. Okay. So it should be precisely. When identifiers A and B are aliases for the same object. So it should be really the same object with the same address. So usually when we have this kind of variable, they have a particular address to place the variable B and C. So for example, A is A. It is true. So it should be precisely the same. Okay. But when we use the equivalency, equal, it can be only based on the elements. So this is using the equality operators. Maybe you already learned Python with very simple like 2 equal 2. Okay, so this is just a simple object or numbers. It is true. Or hello equals hello. It is true. But 2 is 2. Okay. So the more general is using the equal. So is with a literal. So did you mean this one? So this is the syntax warning. Okay. So usually we use the is to understand the variable or the identifiers. Comparison operators. So you already know the less than, equal to, greater than, equal to. And these operators have expected behavior for numerical type and are defined lexicographically. Do you know what does it mean by this lexicographic? So this is the same when I mentioned it's is greater than big H. Okay. Lexicographic, it is based on the character. And it is case sensitive. It is for the string. So you can see if it is A greater than B. So you can express like this one. Or A greater than equal to A. So it is true. Okay. For the arithmetic operators, I think you already know. Okay. Plus, minus, multiply, through division, integer division, and modulo. For the addition, subtraction, multiplication, if both operands have type int or integer, then the result will be integer. One or both operands have type float, then the result is a float. Through division is always type float. Okay? Through division is always type float. Integer division is always integer. So 5 plus 3, it is 8. If I have 5.0 plus 3, then the result is 8.0. So float plus integer, it will be float. Okay. 5.0 multiplied by 3, 15.0. Because it is a float, then the result will be a float. 5 divided by 3, then it is true values, then the result is 1.66666. If we have 5 divided by 3, this is the integer division, then we will get the integer value. And if I want to get the remaining, then it will be, if I using the modulus, we can get the remaining value. If I have 5.0 modulus 3, what is the result? The remaining is 2.0. Okay. Bitwise operators. So these bitwise operators is about the operators for the integer. Maybe let me just show you one example. Usually we use this one for the hexadecimal. Okay. I have one example for, let's say I have 60. Okay. 60, when you represent with the bit number, it is 0011 1100. So this is the bit number in the computer. And then if I have P, let's say I have the 13, and then the bit number of 13 is 0000 1101. Okay, so this is bit number 0 and 1. Okay. So let's say I define C equals to 0, and I want to know if C equals to A and B. Okay. So this bitwise operator, they will change this value 60 into bit number, and it changes this value into bit number, and then do this operation. Okay. I think this is more about the hardware. Okay, this is the machine language. I will not discuss in detail because it is not the human interpretable language. So we have the bitwise complement and or exclusive or shift to the left, shift to the right. Okay. So it is about the semiconductor. They will need this kind of operators. Sequence operators. In the Python, they have the built-in sequence type. So this sequence type, it is belong to the str string, tuple, and list. Okay. So if you have string, if you have tuple, if you have list, you can use this built-in sequence operators. This built-in sequence operator, you can use the variable name, let's suppose S, and then you can use the square bracket after the variable name. Okay. So you already know. Let's say, yeah, I have the A, let's say red, blue, green, 5, 3, maybe brown, okay, maybe like this. So I want to know the A index 0, then it is red. If I want to know A index 0 until 2, A index 0 until 2. What is the result? Red, blue, green, red, blue. Because when we define 0 until 2, it will be the index 0 and 1. Okay. It means if you have 0 until n, it will be from 0 until n minus 1. Okay. If I have a 0, 2, 2, oh, let's say this one is 6, 5. What does it mean? We will get values from the index 0 until index 4. What is index 0? Red. Index 1, blue. Index 2, green. Index 3, 5. Index 4, 3. Index 5, brown. So we will go until the index 4, and we want to skip for every 2 elements. It means I will get the red, I will get the green, and I will get green. Okay, so this is the skip number. If you don't use the 1, the default is 1. Sorry, if you use 1, then it is the default. Something like this. So it will be the same with the A 0, 5. So the same. Okay. If you use 2, it means you will skip 1 and then you will print the value like this. What if I start from 1? Then the result will be blue and 5. The result will be blue and 5 because the limit is until 3 and we cannot go to the brown because the limit is the index 4. Okay. So that's the meaning by the J, it means the index J. And then we have start and stop, and we have the column, okay, between the start and stop. If we have the start and stop and one more, it is about the step. So how many steps you want to check the elements. If you set the step equals to 1, then yeah, it will be every 1 element. If you put step equals to 2, then it will be every 2 elements. So you can concatenate the sequences, S plus T. Or you can have K multiplied by S. It means you want to make it as K times. And you can also check the value, whether it is in the list or not, or whether the value is not in the list or not. So for example, 3 in 8. It is true because I have the element 3 inside the list 8. 4 is not in 8. True or false? True or false? 4 not in 8. It is true because there is no element 4 inside the list A. Okay. And then we can say, for example, B is another list with yellow, or maybe purple. Okay. And then I want to do some addition. A is a list, and then B is another list. And I want to make it in the C, for example. So C will be the addition of red, blue, green, 5, 3, brown, plus the list of B, which is yellow and purple. Okay. And let's say I want to make the B multiple times. So I want to make B 3 times. So I can duplicate yellow, purple, yellow, purple, yellow, purple for 3 times. So that's the meaning by these sequence operators. Okay. So we have the concatenation, we have the K multiplied by S, and then we can also check whether the value is in that sequence or not, whether the value is not in the sequence or not. Okay, I will stop here first. Let's have a break. Okay, I will continue after the break.